Okay, so now we're going to talk about square root and cube root functions. So square root functions are functions that create square root, or contain a square root. Cube root functions are functions that contain a cube root. Now, when graphing square root functions, it really helps to know what the parent function looks like. The parent function of a square root function starts at 0, 0, then there's a point at 1, 1, and then there's a point at 4, 2. And it makes a graph that looks kind of like this. We're going to do all of our graphs stemming from our parent function and using transformations. So we're going to transform this graph, every point on this graph, 2 units to the left and 1 unit down. So the point on 0, 0, 2 units to the left and 1 unit down would be here. The point on 1, 1, 2 units to the left and 1 unit down would be right here. And the point on 4, 2, 2 units to the left and 1 unit down would be right here. And then we can go ahead and erase our parent function and now just resketch our graph with the new graph that's transformed. Now, the reason why we're doing transformations instead of the shortcut ways with square root graphs is because it actually is a lot easier to do it in this way. All right, so same with number 2. So I'm going to just roughly graph my parent function just to show you what happens. All right, so we are going to do a reflection over the x-axis first. So 0, 0 stays where it's at, 1, 1 now goes here, and 4, 2 now goes here. So that's after just doing the reflection over the x-axis, okay? But now I want to vertically stretch this by 2. And so what I do with that is my 0, 0 stays where it's at, but then my slope, instead of going down 1 and over 1, I'm going to be going down 2 and over 1. Because here my a value, well, is -2, so I have a -2 over, my a value over 1 is my slope. However, now to get from this point to this point, I went down 1 and over 3, okay? So that's a different slope. The slope is not consistent with square root functions. So what we actually are going to do here is that slope of 1/3 going down 1 and over 3, well, I guess of negative 1/3, is now going to be adjusted by a factor of 2. So if I multiply my numerator of that slope of negative 1/3 by 2, then I would go down 2 and over 3 instead. So here I stretched vertically like so. This is my new graph. And I'm going to erase the blue one. Okay, looking at number 3, drawing in my parent function, we're going to do this one step at a time. Our first transformation is a reflection over the y-axis. So transforming all of these over the y-axis like so, I can now erase my red parent function. Now I'm going to need to translate all of these 3 units over to the right. And I'll erase my blue graph, and this is my function. All right. Looking at the next one here, now again I'm gonna draw my parent function. Oops, myself. There we go. All right. So now we're first going to do the vertical compression here of 1/2. So my 0.00 stays. But now instead of going up 1 and over 1 to get to my next point on my parent function, I'm actually going to go up 1/2 and over 1. And then instead of going up 1 and over 3 from my second 2 red points, I'm going to multiply my slope of 1 over 3. I'm going to multiply the numerator by 1/2, and I'm going to go up 1/2 and over 3, like so. And now I can erase my red function, because that was my parent graph. And this is my new function. However, that was only after the vertical compression. Now I need to move all the points up too. And this is what your graph should look like. Okay, so now my next one, I'm going to do my parent function again. And all I really have to do in this one is do the horizontal transformation to the left 5 units. So moving all these points over to the left 5 units, I wind up with this as my new graph, and I can erase the red one. And then lastly, so this one's going to be a little tough because now we have a b value, but it's not too bad. So this is my parent function. How I do a horizontal, this would be a horizontal compression, is my slope now, remember, is 1 over the reciprocal of b, so 1 over 1/3. So my 0 point does not move, but I want to go up 1 and over 1/3 to get to my next point here. And then remember the slope that between your second 2 red points is up 1 and over 3. So what I do is I take that slope and I multiply it by the 1 over 1/3. Now 1 times a 1 is a 1, and a 3 times a 1/3 is a 1. So now I'm going to do my slope of up 1 from my second blue dot and over 1. So I'm going to erase my red graph so that way we don't have to. So my first slope was up 1 and over 1/3. My second slope is up 1 and over 1. So let's, and this is what your graph looks like. So when we do the second point on our square root function, you can just use your slope or your a or your 1 over b. But when we do our second slope between the second 2 points, that's where it starts to get complicated. Okay, moving on to cubed root functions, it will help also to know what the parent function looks like. So in a cubed root function, you have a point at 0, 0, a point at 1, 1, and a point at -1, 1, and this is what your graph looks like. So we're going to now just do the transformation here. I'm going to move all my points 2 units to the right and 3 units up. And now erasing my red graph, I'm now going to go ahead and draw the same shape on my blue graph. And that's it. So then my next one here, again, my parent function is 0, 0, 1, 1, and -1, 1. And this is what your graph looks like. Now what we're going to do is with cubic graphs, the slope is somewhat consistent. So if I'm doing a vertical reflection here, this point stays where it's at. And then I can multiply my slope by -2, which means, or the numerator of my slope by -2. So I go up to, or sorry, -2. So I go down 2 and over 1. Or to get this point here, it's already at a -1 slope. So I would go up 2 and over 1. That's just doing the -2 transformation. Your graph looks like this. But now we need to do the horizontal transformation of moving all the points over 1 towards the left. And now I'm going to erase my blue graph. And we're going to draw that new graph in. All right, and then the next one here, drawing in my parent function. We're first going to do the reflection over the y-axis. So 0, 0 stays, but this point moves here, and the other point moves here. So this would be after the reflection over the y-axis, which is exactly what that's telling us to do. And you would have this graph that looks like this. But now I also need to move it up 4 units. So I wind up with this graph here. All right, that brings us to the end of this lesson.